Hello engineers, welcome back. In the previous video, we got the theoretical understanding of topological sort. In this video, we're going to implement it in C++ and see how it looks like. Okay, let's get started. So yesterday we have discussed this example of the study syllabus, and then we have seen how the algorithm works. So first we have an adjacency list, and then we will do a depth first traversal in the adjacency list using a visited vector. And after that, we are going to use a stack to push elements into the stack once we traverse through the edges. And then once everything is done, we'll just pop out elements from the stack one by one, and then we will get our topological sort order, right? So we're going to implement this now. So I've created a new file called topological sort, and I've created the graph that we need. This is exactly the same graph that we have here. So as you can see, there are two edges coming out of 0, which is basic math, and then there are 3 edges coming out of 1, and then we have 2 edges out of 3 and 1 edge out of 4 and 1 edge out of 6, right? So this is exactly the same graph for our syllabus example, right? Now let's implement our topological sort. For that, let's create a new method. Let's call it topological sort. For this, we're going to first implement the depth first traversal the typical way. For that, we will need a visitor vector of boolean, let's call it visited, and this will be of size vertex count, which is the size of the graph, and then everything will be false to begin with. Okay, and then let's create a loop to begin our traversal. Int I equal to 0, I less than vertex count, I plus plus, and then for every vertex we are going to do a depth first traversal. So if the vertex is not visited of I is not visited, then we are going to call our recursion. For this recursion, we're going to take a helper method, and then we are going to pass in our index and also our visited array, visited vector, right? So let's create our helper method. I'll just create it here, void helper, and this will take in an index, and this will also take in the visited vector by address. Okay, so what do we do in recursion? First thing, we will mark it as visited. Visited of index will become true since we have visited it. Now we will call recursion here for all the edges of this index. So for const auto edge, which will come from list, adjacency list, at the index position. So we are getting the edges for each vertex. So we start here at 0 and then we get the edges. Once we have one edge, we go down to that edge and we start with the first node, and then we go down to the other edge, and then we continue like that. So we will call recursion here. If visited of edge, if this is not visited, if it is already visited, no need to revisit it again. If it is not visited, then we'll call recursion with a new index and also our visited vector. Okay, so this is our typical depth first traversal. So we are using recursion here. We started with one vertex, and then within that vertex we are going to traverse through all the edges. Once that is done, we will come back here, we go to the next index, and then we do the edges for that index and so on, right? So this is a typical depth first traversal. Now for our topological sort, what we need is we need a stack. So let's create a stack of int, which will just store the indices. Let's call it topological stack. Okay, and then let's also pass this to our recursion by address. Okay, so what do we do? So what do we do now? We said as we traverse through this adjacency list, right, if we reach a dead end, that is when we will start returning, right? So before returning, we will add the item to the stack, right? So that is happening here. Once we visit all the edges, we will come back from here, right? This is where we return. So before returning, we will just add it to the stack, and that's it. So once we add everything to the stack, once all the recursion is completed, we can just pop it. We'll just pop every element from the stack now, and that will be our answer. So while topological stack is empty, while it is not empty, we will get an element out of it, we will print it, and we will pop it. So int top will be topological stack dot top, and then we print it, and then we pop it. Okay, so I'm using the C++ built-in stack utility here. I'm not using any custom stack utility. So if you want to implement stacks, we have already discussed how to implement stacks. You can use that as well. Okay, and that's it. So let's call our method and see. Oh, small mistake. Topological stack dot push. We need to push the element to the stack. Okay. And that's it. This is our final output. Let's see if this is what we have. So first we have 0, which is our basic math. And then we have 2, which is our geometry. And then we have 1, which is algebra 1. And then we have 7, which is chemistry. And then we have 6, which is physics. And then we have 3, which is algebra 2. And then we have 8, which is advanced physics. And then we have 4, which is pre-calculus, and then we have 5, which is calculus. So this is exactly the same output as we have here. Okay, so our logic is working fine. So just a quick recap, what did we do? We have an adjacency list. We did depth first traversal using this adjacency list, and we kept a visited array to keep track of who is visited and who is not. And once we reach a dead end, once the recursion is completed, when we start returning, that is when we add the element to the stack. And after entire recursion traversal is done, we will simply pop the elements one at a time from the stack, and that will give our topological sort order. So in this order, if I study, I will complete everything while taking care of all the dependencies. Okay, so that is the C++ implementation of topological sort. Now let's also look at the time complexity. What are we doing here? We are just doing depth first traversal, right? And the additional steps are just pushing into the stack and popping from the stack. So this is simply O of 1 operation, right? So nothing major here, but the depth first traversal takes time. So it is exactly the same as our time complexity that we discussed during depth first traversal video. It is O of V plus E. Okay, we are going down one vertex at a time. This is for the vertices, and for each vertex we are going through the edges. That's why it is V plus E. Okay, that is the time complexity. So if you have any questions, definitely ask me. Thank you so much for watching. Do like the video if you found it helpful. Do comment if you have any questions or suggestions. Don't forget to subscribe to the channel. Don't forget to bookmark the playlist and share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.